You for a day with us. Today we are going to have a one-day workshop on structures. It was secret in science, ontology, epistemology, and representation. And so we have to thank our two graduate programs in philosophy and philosophy of science for making this possible. Also, this workshop, as you could have seen in the program, involves the talks of two graduate students from our program. So that's very important for us. The program is paying for this event, so we have to benefit the students, not only allowing them to attend talks. And that's it. It's great to introduce Andres, who's going to be the chair of this session. So, Andres, over it.
Hi, everyone. I hope you're fine. And I'm here to introduce the saint of all theoretical structures. Well, I don't think that he needs any introduction at all, but I had some research, and in his 65 pages CV, I found that he's coming from the University of Miami. He's a professor, and he has been visitor in Princeton, in Sao Paulo University, and he has published in Springer, in CITESE, Routledge, anything. And obviously he has been working in structures, and he's going to talk about this.
Thank you so much for the lovely introduction. Thanks, Maria, for organizing the workshop and all the team here at UNAM. It's always a pleasure to be here and to come back to Mexico City. So today I'll try to answer the question in the title, right? In which, how can models represent possibilities? And it's part of a larger research, articulating a form of empiricism in philosophy that is not afraid of modality, right? Actually embraces modality. And that shows also the role that models as particular structures play in scientific representation. Right? So to begin with, so scientific models, they're clearly are designed to represent what is actual, right? From which predictions typically are made, right? So in the inferential conception that I work with Stephen French and Mark Oliver, a central component of scientific representation involves setting up mappings, right, from empirical setup to parts of the relevant models, right? So, of course, the whole point of doing that is to find ways of representing the action, right? We're interested in what's going on, right? Now, what goes on in the empirical setup clearly has counterpart in the model, right? As long as the constraints of empirical adequacy are met. So that's when the minimal constraints should be satisfied. But then the question arises, how about what's just merely possible, right, but not natural, right? These kind of phenomena are also relevant, and they need to be represented. So what's the story about that? And what I'm going to try to do is to address that sort of question. So part of the idea here is to explore surplus structure, right? To access structure that models typically have, especially mathematical models. Because I think properly interpreting these surplus structures gives us a path to those non-actual possibilities. Now, models are often built in, they have a built-in structure that will locate the phenomena among these possibilities, right? And then the question is, well, how can these structures be known, right? What are these? Isn't this precisely the kind of information that the model is supposed to provide in the first place? So I have a sort of a chicken and egg situation here, right? Because the models are meant to represent possibilities, but to find out the possibilities so that the model can represent them, you already have to know those possibilities. So how can we get this off the ground, right? So I try to address, at least in part, this challenge first by drawing a distinction, right? Um, so I draw a distinction between a condition for a model to represent, right? You may think of this condition as a blind spot, a hinge, depending on the metaphors you want to use, right? But there are certain features in the model that allow for representations to emerge. You need to be hard fast, otherwise the model will not work as intended. Another thing are the representational possibilities that the model encodes, right? And these two things have to work together carefully so that the model can represent properly, right? Of course, both features are revisable, right? And of course, you change the model as needed to adjust, right? And then, but without a proper balance between these two, negotiating these two things, and I'll say more about that in a moment, the representation via models will become just impossible. So what I'll then conclude is indicate how by paying attention to how this works and working through some examples, right? What we have is a modalist empiricism form about scientific representation. Okay, so that's what we have for today. So I'll start just reminding the central features of the inferential conception that I'm going to be employing as a framework to think about scientific representation. Of course, this is nowadays there are a million different views about scientific representation. This is just one among many, right? It happens to be my favorite one, so but not that it works perfectly, but it's good enough, right? And the central idea is we start, with an empirical setup, right? So something that we're trying to represent, understand, account for, and we have a certain model, typically a mathematical model. And we're going to select certain features from the empirical setup to have counterparts in the model, right? That's an immersion. An immersion is a mapping from bits and pieces of the world into bits and pieces of the mathematical model, right? Once you have that done, the model has an internal dynamics, right? That's the whole point of having the mathematics, right? All kinds of inferences can be drawn from within the model. This process is entirely mathematical, right? What you get here as the result is a certain mathematical bit of information. That mathematical bit says nothing about the world until it's actually interpreted back in the phenomena. And that's the central idea of the inferential interpretation, right? So this is actually a generalization of Rig-Hughes' account of called DDI account. It's just that the DDI is denotation, demonstration, and interpretation. The denotation, he takes it to be a denotation function. That's too restrictive. So because, for example, I cannot denote an object that doesn't have well-defined identity conditions, because the notations will be completely unwieldy in that case. But I can immerse, right? If I can have a map, an unsharp map, for example, from bits of the model bits of the world into the model, and in that way I can, represent quantum known individuals, right? In a way that the standard formulation of the DI account would not allow, right? Similarly, the interpretation here is far looser, right? As strict as the DDI has, right? So it's meant to be a generalization of the DDI account, and it's meant specifically to think about the way mathematics is applied. But of course, it also tells us something about scientific representation more broadly. All right. So let's then go back to the issue that I was raising about, encoding possibilities in a model, right? So a model typically includes a whole range of possible outcomes, right? All the outcomes that the model recognizes as possible. How can we know whether we have all the possibilities, right? So you may say, well, are we missing something in this model, something relevant, right? So it's in this context that I said the distinction that I mentioned in the introduction, right? Conditions for a model to represent is one thing from the representational possibilities encoded in the model. Let me say a little more about that. So let's consider a simple example to illustrate, right? As a good empiricist, I work from the bottom up, right? I look at a particular example, try to understand how it works, and see which features it may illuminate, right? Rather than come up with a big, questionable, problematic theory and infer from there. Okay. So a simple, think about we have a fair die, right? So there is a sample space, right? Consisting of all possible outcomes of rolling the die, right? Corresponding to each of the 6 faces that the die can land on, right? Now, these are the representational possibilities encoded in the model, right? The model represents all of them. And there are supposedly all the possibilities. There are only 6 of them, right? 6 sizes of 6 faces of the die. And okay, we cover all possibilities, right? If you take then each possible outcome, the particular face that lines up as having equal probability, the model represents the die as being fair, right? And that's exactly how fairness is then characterized in terms of equal probability of each possible outcome, right, of the rolling die. And then we have a probability, it's 1/6, right? So far so good. This is all simple, standard, right? But then you may wonder, okay, whether in fact all possibilities have indeed been encoded in the model, right? For example, how about the possibility that the die lands on any, not in the face, but one of its corners, right? Sure, very unlikely, right? But given the sample space, this outcome is just ruled out by fiat, right? It's not recognized as something possible. It's not even in the model, right? And that's one way of saying, from the point of view of the model, this is not a possibility, right? There's a probability of this outcome will be 0, right? There's no chance of that outcome ever showing up, right? Since it cannot obtain anywhere in the model, right? Despite that, I think we want to say that arguably, even though it's very unlikely, it's not impossible that the die will land in one of its edges, right? So perhaps you die in a little crack on the landing surface, right? So, okay, but that's not a possibility that the model allows for, right? So think about this, right? So the situation there is, in order to represent the die as being fair, right? Every possibility has equal probability. It excludes the possibility that the die will land in one of its corners. Right? So arguably, the possibility of that happening, right, is less likely than the possibility of the die landing in one of its faces, right? But to recognize, right, the corner landing possibility would actually end up undermining the way in which the model represents the die's fairness, right? Since in that case, not every possible outcome in the sample space will have the same probability. So if you allow for that as a possibility, right, that would put in jeopardy the idea that, well, this is a fair die, every possible outcome has equal probability. Well, if you recognize something as being possible, right, well, then that's no longer the case, right? So the way that the model has been designed, it doesn't even acknowledge this as a possibility, right? So in fact, the model would exclude that from happening, right? It's not one of the outcomes. But not so, as I said earlier, one thing is a phenomenon that is highly unlikely, right? Maybe has probability 0. Another thing is a phenomenon that is impossible, right? And that's a distinction that we want to draw. And the model doesn't allow us to do, because it just lumps the highly improbable as something that is impossible, because there's no way in the model to represent that as a genuine possibility. So strictly speaking, in the model, the die landing in one of its corners is not a possible outcome. Thus, the fairness of the representation can only be achieved by failing to represent all possibilities. And I want to say that's how, in this simple case, the distinction that I drew between, the representational possibilities of the model and what I'm calling the hinge, right? What is it that allows for these possibilities have been negotiated, right? You rule out certain things as not being allowed in the model. There has to be fixed so that the model can represent fairness in a way that it's not dependent on these outcomes. Thus, the condition for the model to represent fairly limits the representational possibilities that the model encodes, right? And that's the way in which, in that particular simple model, this trade-off was negotiated, right? It is a trade-off, right? You could complicate things. You can complicate the model, say, okay, all right, there are more possibilities than the model allows for, right? So, and then how do you represent fairness, right? It's not as easy anymore, right? Because now you're dealing with other possibilities in that case. So we'll complicate the model, right? And so you can see why, for simplicity reasons, that was the trade-off, right? But it's one that you may ask for the accuracy, right? If you want to really take seriously that I'm going to take into account all possibilities. Well, then I need a better model than this one, in which that trade-off is not done in this one. Okay. Now, so the conditions for the model to represent, you can think of them as hinges, right? Blind spots, artifacts of the model. Whatever things that they need to be held fixed so that other parts of the model can do their representational work, right? They are required so that the model achieves its representational possibilities, but there are built-in constraints in the model. So there are certain things that the model cannot represent so that it can then represent other things. Right? So that's the idea of what's happening here. So now consider the Lotka-Volterra equation that, for those of you who were yesterday in the talk, I talked a little bit about, right? I'm going to spin in a slightly different direction for the purpose of this talk, right? So this is a couple of differential equations that represent cyclical phenomena, right? Such as the relation between, growth of the population of predators and prey. Right? The model makes a bunch of assumptions that are clearly false. It's a highly idealized model, right? And without these assumptions, the model simply doesn't work, right? And you have assumptions such as that the population is infinitely large. The prey population is infinitely large in the limit, right? The size of the population is continuous, right? So there are no jumps, or it's just grow sort of in a continuous way, right? The prey population reproduces asexually, right? So there are no the variations, and so the whole thing is, of course, all of those things are false, right? And those specific lists, the assumptions that I list there, are there so that you can apply analysis, mathematical analysis to the model, because otherwise the mathematics doesn't work, right? You cannot do that with the discrete phenomena. You need some continuous, so you can apply the functions that are going to be the results of those differential equations. So these are built-in assumptions that need to be there so they can then use the mathematics so that the mathematics can represent the phenomena, right? So the continuity of the population is required, given, as I said, the use of mathematical analysis in the model. So classical solutions of differential equations will typically demand that the functions involved to be continuous and differentiable. And so you need to have a continuous growth of the population. The continuity of the population size is then an artifact, right, required to represent the cyclical structure of the model. Once you fix that, right, then you can represent the cyclical phenomenon. But that part is now held fixed. And of course, it comes also with all kinds of additional artifacts, if you want, because if that growth is continuous, well, then it can, at any point of the growth, it can be infinitesimally small divided, right? So you can now divide bits and pieces of that population in this infinitely small, which of course we can't do it, right? Now, the model, in its simple elegant mathematical representation would do something like this, right? So you have, the population, as the prey population grows, there is easily available food. So there's more food, the predators, the population of predators also grow. But as the predators grow, well, they start eating a lot of the prey, and then the prey starts to go down, and that will cause, going down in the, and then you have the cyclical structure, right? Now, without the idealization, so if you try to measure, exactly what goes in the wild, right, you get something more or less like this, right? Doesn't look as neat, as elegant, right? So you can see kind of, a correlation, but of course there are, in reality, all kinds of other factors, right? You see here the population of the prey just going on. It's because all kinds of other things happen in the wild, right? Yesterday, Sazik was saying, well, sometimes the prey decide just to go away, right? They move, they relocate, right? Well, there are too many, predators in this area. You're going to find better mountains, right? And sometimes there will be plagues, diseases, all kinds of things, right? And or too many hunters. All kinds of other things can happen, right? So in this case, this was actually numbers, back in the end of the 19th century, beginning of the 20th century in Canada, comparing, hares and mice, right, and how the two are connected. So in light of this, is a challenge, right? It's a challenge that Peter Tan has recently raised exactly about models like those, right? And he raised two epistemological challenges to what they call these hypothetical models, right? These are models that involve non-actual but possible targets, right? No population growth can be continuous, right? And then so the Locke de Voltaire is an example of that. And here's what he says. So the first epistemological challenge is that no account for the epistemology of hypothetical models seems to cohere with the most characteristic function of scientific modeling in general, i.e. surrogate representation. So, wow, look, how can I explain? So, the models talk about things that don't exist, right? Okay, that's an epistemological challenge. The second one is a version of the reliability challenge, familiar from other areas. And Tan says, there's a challenge to explain how hypothetical models could be reliable guide to what's possible, given that they are not and cannot be compared against known actual targets and updated accordingly. So you cannot even explain the possibility of representing things because they're representing things that don't exist. So how can you tell that they're representing well? Right? So these are the two challenges. I'm going to spell them out a little bit in the way that Peter does, and then we're going to see how we can respond to them. So let me say a little bit more along the lines of the first one. So Tan says, to take the Locke-Voltaire model, the model comprises a pair of coupled differential equations. Interpreted literally, if it were objectively possible for there to be a Locke-Voltaire ecosystem, there would be possible ecosystems that contain infinitesimally small fractions of organisms, right? That comes out exactly because of that continuity, right? So, but this is definitely nomologically impossible, right? Whether one considers these kinds of possibility claims the re or the dicta, they still look to be flat out impossible, i.e. metaphysically impossible. The re would be possible for would it be possible for the very sorts of things that actually are organisms to be infinitesimal fractions? Definitely not. The dicta, would it be possible for an infinitesimal fraction of an ideal organism to fill the causal roles that predators and prey organisms actually fit? Again, quite plausibly not. Even if the realm of objective possible is expanded to include things that are nomologically impossible, turn off your cell phones. Okay. Boy. All right. Sorry about that. It's my dealer, car dealer, not the drug dealer. Also could mean lots of things. No, my car dealer. It's all right. Okay. Exactly. Now I'm on record. Okay. Okay. So even in the realm of the objectively possible, we expand it to include things that are nomologically impossible, but in some sense metaphysically or flat out possible. Some hypothetical models still appear to be mistaken about what's objectively possible, right? Because you're recognizing as possible something that clearly is not, right? So there is a problem here. In light of considerations like this, then is the issue that becomes, right? Then says, under what conditions would there be evidence that a particular model really does manage to represent something that is objectively possible? So the issue here is straight on how can make sense of the way in which models represent possibilities, right? Hence the title of my paper. And the primary epistemological challenge is that evaluating the surrogative function of hypothetical models is pretty much impossible. How are we to evaluate whether the predictions generated by one of these models obtain in their purported target, right? If the target do not exist, are impossible, how can we evaluate this model? Non-actual possibilities certainly can be observed. Manipulation is right out of the windows. We can manipulate or intervene on merely possible ecosystems or markers or selection processes, right? So all the familiar tools to intervene and get some information about are not available. So right off the bat, if the targets of hypothetical models really are non-actual possibilities, it looks like there is no epistemic access whatsoever to evaluating how well they perform their function as surrogative for the targets, right? So that's the case for the first challenge, right? Now the second one. Peter tells, the second epistemological challenge that we should raise is the following. Given that even the successful hypothetical models are not evaluated against their targets, what could explain the fact that some of the models nevertheless manage to get the targets right? So isn't it amazing, right? Despite all of that, we have no proper epistemology of what's going on, the models work. How is that possible, right? If there really is a lack of connection between the models and the targets, there should be some account of how the models nevertheless manage to be reliable with respect to what is possible. All right, so these are the two challenges, right? Two epistemological challenges at issue here. What can we say in response? In particular, what can an empiricist sympathetic with the inferential conception could say, right? So first, I think Puritan's critique has a presupposition that we should not grant. Right? So the hypothetical models, those that represent non-actual but possible targets, are allegedly not evaluated against their targets, since these targets do not exist, right? That's a crucial assumption in the project. But there's no need for us to assume that that's right? Why? So, because look, if you think about the Lotka-Volterra model, it is about predators and prey in the world, right? It's about rabbits and lynx, right? I gave you the data about those things. Existing creatures in the wild. That's the target. The target's not possible rabbits that could be sliced infinitesimally and small, right? The target of that model, imperfect, idealized as it is, are actual objects in the world. So we shouldn't grant the idea, oh, because there are those non-actualized possibilities in the model, then the model is about those things, right? So resist that, right? Now, the model represents things counterfactually. That's the beauty of the model has modal relations, right? And what it does is exactly exploring counterfactually what would have happened had these objects being able to do these things, being able to have these properties, right? The continuity assumption in the model would allow, sure, for infinitesimal fractions of organisms. But this is not the property that real rabbits have, right? And that's where the inferential conception comes in. right? Remember the key last bit, the interpretation bit, right? We immerse the model, the bits in this empirical setup in the model, then we derive within the model with all the infinitesimal parts and all the resources of mathematics, the result, and then we're going to interpret back. So that interpretation is crucial. And in that interpretation, you're not going to interpret back every single aspect of the model. In particular, you're not going to interpret back fractions of rabbits, right? Infinitesimal fractions of rabbits. They have no counterparts in the world. So you're not going to represent that. So in the interpretation part, you're going to, just as the immersion part selectively chooses portions of the phenomena to have counterparts in the model, the same thing happens in the interpretation bit. Portions of the results are going to be interpreted back in the world, right? So you don't take every part of the model, including those that are you've been reasoning about them within the model, right? So you don't the infinitesimal portions are not going to be interpreted in that way, right? So once you avoid that kind of reification, namely, because I think that's what Peter Tens is doing. He's reifying the model. Every bit of the model has to have a counterpart in the world. Well, the world doesn't have that, so every bit of the model is talking about some non-actual world, some other thing. Resist that. Don't reify. Right? Be selective. Right? We're going to only interpret some portions of the model. So if you avoid that kind of reification and interpret carefully the mathematical results, it is a central feature of the inferential conception. Right? Be selective. And that's what good empiricists do. Right? You select what you have evidence for and what you don't. Right? And that's exactly what I advise in this case. Right? So consider, for example, the Tarski-Banach theorem. Right? So this is a result in analysis. We need the axiom of choice to prove. But you have, basically, you have this three-dimensional sphere, right? And you can decompose that sphere, right, into finitely many disjoint subsets. And then you reassemble these disjoint subsets into two spheres of the same volume as the original one, right? You may look at this and said, interesting. Does that mean that I can get an orange, slice it, and rearrange into two origins, right? It would be very neat if I could, right? Well, we'll solve the problem of hunger in the world, right? So, and of course the answer is no, right? And the reason why it's not is because the decomposition that in the Tarski-Banach theorem that we are doing is we have actually a scattering of infinitely many points. And that's where we need the axiom of choice to reassemble those things one by one to get to the two things, right? Without the axiom of choice, you can't do that, right? But of course, when you slice your orange, you don't have that kind of scattering of infinitely many points. No concrete object can be decomposed in that way, right? Again, this is a part of the model. You do not interpret back in the world. It would be a mistake if you were to do that, right? So anyone who wants to say, well, look, I refuted the axiom of choice because I have this orange in my hands and I slice it and I cannot put together two, right? So the axiom of choice, you may have all kinds of worries about it, but that would not be a good argument against it, right? It was just a mistake. And the mistake is in the interpretation of the result, right? So it's exactly the interpretation bit when you are refining the model, right? And over-interpreting more than the model allows you to do, right? So that's exactly, the way in which we would resist, right, on the inferential conception, that sort of maneuvering, right? And I think Peter Tens' critique is assuming a form of reification about the models, right? So that's what I'm suggesting we avoid, right? Now, I don't know, there was some obviously problem with the formatting here, but the point here is when you interpret the result, one constraint there has to do with empirical adequacy, right? Because you want your model to capture the phenomena, right? So you have to find ways of interpreting the model that are empirically adequate, right? And that's an important constraint. So if you have an interpretation that is empirically inadequate, well, then that's a problem for the interpretation. You have to find a better one, right? And that's how you avoid misinterpreting, the Tarski-Bellner theorem in this case. Okay. So now, how can the reliability of a model involving non-actual but merely possible targets be assessed, right? That's the other critique, right? That I said, well, we cannot assess, the models, hypothetical models that talk about non-existing targets, because, well, we're talking about things that don't exist, right? So how can we possibly assess them, right? Now, I want to say that the assessment is made on the modal properties of the objects. Objects have modal properties. This table, right, is fragile, right? So that's a modal property that it has. It's a property that it has as much as having a certain shape, being made out of certain materials, right? And because objects have these properties, models will try to track them, right, and find corresponding features in the model for these properties. Now, hypothetical models involve reasoning counterfactually about objects in the empirical setup. Of course, when you're reasoning about this, you're doing that inside the model. So you need here to track these two things. One thing is the object in the world, the other thing is the representation of it within the model. Now, how reliable is such a counterfactual reasoning? Right? That's the objection here, right? Now, we determine the reliability of the reasoning by comparing the conclusions from the model with the empirical setup and interpreting the conclusions in the ways that preserve their empirical adequacy. So that goes on with my first point, resisting Kant's critique. The Locke-Volterra model is about not possible preys and predators that could be sliced in infinitely bits, right? But actual rabbits and lynx in the world. And we're going to compare the results of that model with the information that we have about the population growth with that one. And we're going to only infer in bits of information that are adequate, given what we get about the world. And we're going to correct the model. Maybe there's no way we can interpret the model in a way that it's coherent with the empirical data. In that case, we say, look, that's a terrible model, right? So, and we just reject the model and altogether. Because in a way, what the model does is to allow us for representing possibilities, right? And these possibilities have to be interpreted. Since there is no infinitesimal fractions of organisms in the world, this aspect of the model is not interpreted as corresponding to the part of the empirical setup, right? So there's no mystery. You're not comparing the model with a known actual possibility. I don't know how to do that, but I mean, we don't have to, because we have rabbits and lynx and then doing their things in the world. And that's what we're trying to understand in any case. Right? Okay. So the cyclic connection between growth of the population of predators and prey does capture a salient feature, right, of the empirical setup, right? And that's what we're going to rely on when we try to evaluate the model. We use that kind of actual information, right? Even though the model incorporates possibilities that are not actualized. Okay. So to sum up, there are two regions here of possibility on this account, right? One is the model properties of objects in the empirical setup, right? Predators and prey doing their things, right? What they can and cannot do, right? And the other one is the possible configurations in the model, right? Which allow for the model's representational possibilities, right? That we talked about in the beginning of the talk, right? So there are modality on both sides, right? Modal properties of objects in the world and modal properties of the mathematics, right? In the model, right? So the source of the modality is clearly in the world, right? That's what we're trying, objects with their modal properties. That's what we're trying to understand, right? And the empirical setup, we extract, right? Select some of those properties for representation in the model. So an empiricist, I want to say, it's a realist about the observable, right? So what should we say about those objects, the modal properties of these things, right? Now, unfortunately, empiricists historically tend to have a ridiculously narrow understanding of what experience is. And I think that's why they end up being so skeptical about modality, right? So if you think about Hume for a second, right? Good old David staring in front of the mirror, right? And he's staring there trying not to blink, right? But after a while, he blinks. And then he looks back and he's not sure whether what he's looking at is himself because, well, I don't know, right? So he concludes that, well, I don't even know whether I have the same self, right? Because the experience is so tiny, right? That I'm now making an inference where after blinking that, well, it's the same object, right? Is it? So now that, I think, is a way of thinking about experience in a ridiculously narrow way. I think experience is richer than that, right? I think good old David should blink and say, yeah, I'm still the same, right? You know, he may over time complain, yeah, I'm getting some weight here, but, you know, the food is good and so on. You know, I'm having fun with my friends, dining and so on, and life is good. And but the idea here is he can experience possibilities, right? He's not acknowledging because he thinks his experiences are too limited, but he can see that he's the same. I can see that this table is fragile. I feel it in my hands, right? I can even experience impossibilities, right? Doesn't matter how hard I push this wall. It's impossible for me to move it 1 inch further, right? And I can feel that, right? Of course, not every possibility is like that, right? There are possibilities that, you know, we need some reasoning. You may need to have some information about other things, but a lot of them are. And we learn about the world exactly like this, right? What's possible to do, what's not possible, what I can or cannot, right? Otherwise, we die, right? If you think, okay, I'm going to leave the building from the 10th floor through the window, right? Bad idea, right? Those who keep doing that will die out, right? And then eventually, you know, people stop doing that, right? Or the population vanish, right? If everyone did that, right? So there are certain possibilities that you need to be able to recognize, right? And that's part of our way of learning how to deal with the world, right? So these are modal properties of things, right? So we observe possibilities, or at least some, we observe some impossibilities as well, right? But it's what's important and it's crucial here is, just as we should not reify the models, we should not also reify these possibilities. When I'm talking about possibilities here, I'm not talking about what's true in a possible world. I'm not talking about an instantiated universal. I'm not talking about a whole class of abstract propositions, right? Or combination of state of affairs, right? These are all what I call metaphysical reifications. You're reifying something that actually have a much better understanding without the metaphysics into something that it's actually very mysterious. Why should you do that, right? So I think the other reason why empiricists traditionally have been so allergic to modality is because of this conflation in philosophical circles between the modal and the metaphysical, right? Because, well, if you're talking about something possible, oh, we need to talk about what's true in the world, we need to talk about in an instantiated universe, and all of those things are things that empiricists rightly are very skeptical about. So don't, right? So when I'm talking about possibilities, I'm talking about things that are very straightforward, right? Like shapes of tables, right? Fragility of things that we are all familiar with. And I'm resisting the philosophical glossing that the metaphysician, invites us to give over those things. I think this actually obfuscates, confuses our understanding of what's possible rather than help. Right? Often, unfortunately, philosophers have this tendency of thinking, "Oh, we need to reify. If you don't tell me what kind of thing it is, right, I don't know what you're talking about." And I think that's not right. Right? It's unnecessary. So I'm not going to do that with the modality. And when I'm talking about possible things, that's what I have in mind here. Right? I'm not reifying it, not course, I'm taking it ultimately as primitive. I don't think we can define what's possible in some non-modal terms. Okay. I think similar considerations apply to the representation of possibilities in the model, right? I talked a little bit how to resist verification, about the objects in the empirical setup, right? Similar things apply to what goes in the model, right? We also do not want to reify the mathematical objects that are being used in the model, right? On the inferential conception, the immersion step involves mapping select features of the empirical setup into the model, right? The exploration of structural resources in the model, the possible configurations that the model provides, implemented on the inferential step, requires no reification. So when I'm talking about mappings, functions, and things like that, you may say, you're a Platonist. You're using mathematics, right? Also, in your model, you're talking about differential equations, solutions for those things. Those are functions. Right? All of those things are abstract objects. They are things that empiricists should not be happy with, right? Right? So now, I want to say, we can quantify over all of those things, right? Draw inferences from them, right? Refer back into the world in the way that I've been talking for the last, 40 minutes or so, right? But avoid commitment to their existence. The fact that we quantify over something doesn't entail that that something we quantify over exists. That's another piece of conflation that, unfortunately, in that case, the Quinian has sort of imposed upon us, right? Well, if the thing is indispensable to your best theories of the world, it has to exist. You cannot possibly quantify over them and deny the existence of those things. This is double thinking, and so on. You're all familiar with kind of indispensability arguments that Quine had, right? So I want to say avoid that, right? Do not conflate existence with quantification, right? So those are two different things, right? Quantification is something that helps us specify among the objects you're quantifying whether you're considering some of them, that's existential quantifier, or all of them, that's universal quantifier. None of them need to exist. We can quantify over things that do not exist. In fact, we do that all the time, right? So I talk about, fictional objects, right? So Sherlock Holmes, right? And he has some properties. He's a detective. Sherlock Holmes cannot fly over the Atlantic unaided, right? These are all true things about them, even though it doesn't exist, right? And I'm quantifying over it, right? You may say, well, it's in the fiction. So in it, and add need to add these things in order to be able to do this. Well, maybe I do, but interestingly, when I'm reading a novel, for the novel to work, I cannot do this in the fictional brain, right? I need to immerse myself into the story, right? And interestingly, I can understand the story, figure things out without assuming that the thing exists at any moment at all. In fact, it doesn't confuse me for a second, right? So you're going to do exactly the same thing with mathematics. I'm going to use the mathematics, draw the inferences about that I need to do for the differential equations and so on, without ever thinking, okay, this object is an abstract entity that exists independently of me. That's a refined interpretation of the mathematical formalism. That's a Platonist reading. You need not be a Platonist to use mathematics, because you need not add this extra bit of metaphysical interpretation, right? You just say, look, they're objects, right? For example, I'm talking about metric spaces, right? They're distances, right? And distances are positive if the points in the space are different, right? Between 2 points, the distance from one to the other is the same from the other to the first, right? So these are all properties that these things have. I don't need to give the extra step and say, and by the way, these objects exist and they're abstract. If I don't do that, I'm quantifying over them in a neutral way, without assuming that they exist. If I want to say that they exist, I need to add an existence predicate and say, okay, they have to satisfy whatever property that an existent predicate is meant to satisfy. And if they do, okay, then they exist. If not, they don't. Turns out, I don't know whether mathematical objects exist or not, right? Because I don't think we can offer an account of existence that doesn't beg the question against the Platonists. Maybe I can offer sufficient conditions for existence, right? Something is located in space-time, if it's causally active, normally those things exist. No one normally would have qualms about their existence. As a sufficient condition, that goes all right. If I say, oh, by the way, this is also a necessary condition, then we run into trouble because the Platonist says, well, wait a minute. Numbers exist, but they're not abstract, they're not causally accessible, right? And so they'll complain, right? I cannot prove that numbers do not exist, as the Platonist thinks, right? But I don't need to prove that they don't in order to use them. Nor do I need to assume that they do in order to use. I can remain neutral, agnostic about their existence, and still use it exactly as the way I've been talking about, right? That's the way I would have, in that way, I avoid reification of the mathematics and the model, and I avoid reification of the modal properties in the world. Of course, the mathematics also has modal properties, right? There are certain things that are possible or not, given the results of mathematics, right? I'm not going to reify those either, right? For the same reasons, right? I recognize the modality, I just don't reify it, right? Okay, so to conclude, whether we consider model or objects in the corresponding empirical setup, there's no need to reify the items involved in their characterization, right? Models represent possibilities because they have structural configurations that can be taken to correspond to certain features of the empirical setup, right? Modal properties of objects yield possibilities, which are in turn represented in the model. So there are modalities on both sides of the equation, as it were, right? And even non-actual but possible targets. Okay. Not sure about. Okay. Thank you. All right. So even non-actual but possible targets can be accommodated, right? By reason counterfactually from the model, but without attributing to the objects in the empirical setup those properties that were introduced in the model as artifacts of the representation. Right, and that's what we saw in the Lotka-Volterra, and also in the case of the scattering of infinitely many points in the Tarski-Banach, right? So in both cases, the idea is we can understand how it's possible for models to represent, right? They allow for possibilities to be represented. That's what they do, that's what the mathematics allows for. But when we interpret the results, we try to capture modal properties of things, but they're interpreted in a way that also do not reify them. Right? So in that way, I think you can be a good empiricist, right? About these possibilities without reification, right? And what we have is what I call a modalist empiricist. And that's what I offer as a way of thinking about representation. Thank you very much.
Okay, so any questions? First, second, third, fourth. Okay, I'm going to try to be fast because I have a couple of questions. First is that it seems to be you may be assuming that it's kind of easy to separate the elements that are reifying the model from the ones that are actually going to be transferred to the target once you interpret it. But where does your confidence come from? Why are you so optimistic that there's not going to be an issue? Yeah.
No,
can I do the second one? No.
That's the one, and then we do the second. So I agree. Look, I don't think it's easy, and in some cases we don't know how to do it, right? And in some cases we know that there is something awkward with the model, that we don't have anything better to do, so we kind of stuck. We do the best we can until we find a better model, right? I would say that those things are learned on a case-by-case basis, right? Now, models are designed in a way to help us understand what these possibilities are, right? And in that design, there's a lot of simplification that goes in, right? So that helps constraining right? Among the plethora of possibilities, which are those that we think we can represent in the model, and then draw some inferences, and then try to get conclusions back, right? In some cases, we don't know, right? Sometimes the model may have a surplus structure that we don't know what to do with it, right? The example I love to give, we talked about last night, the Dirac equation, right? With the negative energy solutions, right? He responded to that saying, well, we have these negative energy solutions, they don't mean anything. It's just like classical mechanics, ignore it. Then he came back 2 years later and said, no, that was too quick. These negative energy solutions are holes in the space-time. And then he said, Weil and Heisenberg immediately pointed out, according to this whole theory, protons and electrons has the same mass. But that's just empirically wrong.
Yeah.
So rule that out. 2 years later, new interpretation. Forgot about holes. What's really going on is negative energy solutions stand for a new particle. There's the same mass as the electron, but the opposite charge. That's impossible, right? So the same mathematics, three entirely different interpretations, right? So we don't know, right? So it would have been very easy for Dirac simply to ignore that surplus structure. So that was his initial reaction. This thing doesn't mean anything. But he was puzzled. He said, well, maybe there is something. Maybe there is something in the model that I can explore. What the model is doing is just allowing for some possibilities. Now, the work of the applied mathematician and the physicist is that you figure out. He doesn't know, right? So I'm not saying that it's easy. In fact, it took Dirac 6 years to work this through, right?
But then what kind of time come back and say, well, yeah, your solution assumes that we can make the distinction. But given that de facto we cannot make it, then at least the epistemic challenge, at least the first challenge is going to be still in place because we don't know whether we apply the model, and yet we don't know whether the elements that are metaphysically impossible are being reified or are actually part of the representation of features of the model.
We don't know it, but it's an empirical matter. We're going to find out. Because the reason for him why that was impossible is because he reified the model and said, well, these surplus structures stand for non-actual things. Yeah, that's why I'm resistant.
The question is who has the burden of proof. Okay, no, I'm sorry, I already went.
In the following respect, right? Because if by force, so every element in the model needs to correspond to something in the world, and if there isn't anything in the world, then it's some other world or some non-actual possibility. It's by making that move that then he created the problem. So and I'm denying that you make that move. And when you don't, so first, you are no longer interpreting the model into something non-actual. You're refining, because you want a model to talk about the world. So you're constraining or allowable interpretations on things that can be empirically checked. Now, because it's an empirical matter, I cannot know in advance, right?
Yeah.
So, and I think it's unreasonable to say, oh, you need to know the answer ahead of time to address that challenge. I don't think that's right? Because it's an empirical challenge. Mm-hmm. The only way to address an empirical challenge is empirical, right? To actually figure it out. Some cases it'll work, some cases it doesn't. But what we have here is a path to how to do it. Right? Good. And that's what I'm trying to offer, right? So, okay.
So that challenge is an open challenge and it's going to be solved case by case. You cannot just say like, tan is wrong overall. It's like, you have to, the challenge is a good one, and we have to go and check that the parts that are causing these problems are always over-reified and never something that is going to translate.
Yeah, I think it's saying a little more because I think he is assuming, right, this non-actualist bit, and I'm resisting that. I'm saying, no, don't do that. And if you don't do that, you can, in effect, address both challenges at once, right?
Because that was pretty good.
Yeah. So in that way, because now it's an empirical constraint.
Yeah.
Right. Now I cannot know in advance the answer, right? But I don't think the challenge was an in-principle challenge, right? It wasn't a challenge about, okay, tell me in every single case what's going to happen, right? Because that was never the case, right? The challenge is, how is it possible for models to represent possibility if what they represent doesn't exist? Right? And I'm saying, well, this is how is it possible, right? But not refine the model and finding empirically constrained interpretations, right? I'm responding to an impossibility challenge by showing how is it possible. But the only thing I'm giving you is a path.
Yes, not that. Yeah.
But I thought that's how we respond, right? If the challenge is it's impossible to do that, if I show that it's possible, that's a response, right? I don't have to say it's actual. It turns out it is. I think there are examples that also illustrates that, right? The direct example and so on.
Yeah, I think I have already talked too much. But
That's fine, but if you're looking go
Yeah,
to
exactly.
you for the
And the end,
rest of
exactly.
this.
Okay, so we'll talk more.
yes,
Nothing.
I'm really interested in your project because it's a very real problem. How can I understand a model talking about something that doesn't appear to exist?
Yes.
But I'm not completely sold out on the idea of, well, you're somehow talking about actual things.
Mhm.
Maybe indirectly, but maybe combining them in some normal way. But at the end, you're talking about real things. Because I want to give space for bad science
Mhm.
and incomplete science
Yes.
still being empirical.
Yep.
So science that talks about things that do not exist, maybe dark matter doesn't exist, maybe astrology has it all wrong,
Mhm.
but it can still be empirical,
Sure.
at least in some versions, and have models that are acceptable. They're good models. They just don't happen to describe anything that does exist. And you cannot say, well, he's talking about real things, just got it wrong, the properties that they have, because sometimes neither the objects nor their properties really come to pass. So how do you handle those kind of problems?
Well, look, I think that has happened many times, right? Because we thought we were describing certain things, right? And for a while, we kept talking as though we were until we learned that we didn't, right? Think about Newtonian physics, right? For centuries, we thought, okay, yes, there is gravity, right? It's just force acting, on bodies that affecting every bit of the universe, right? And we did not realize that conception of gravity is mistaken. There's no such a thing, right, in the world, right? Relativity is right. Gravity is part of the curvature of space-time, something completely different than what was going on. So there's a sense in which we were describing something that doesn't exist, right? And now we meant to be talking about the planets. We meant to be talking about the action on those things all along, right? And so we're not, even though Newtonian physics, strictly speaking, right, is describing point masses, right? So it's describing an idealized, abstract model, right? That's what it's describing. No planet has all its mass in a single point, right? So, and you have to say, okay, but to describe the planet, will get too complicated if I have to take into account all of these factors, and I have something that is computationally intractable. So I have to simplify, right? Now, so at that point, Newtonian mechanics is actually describing a mathematical model, not the world, right? So then I have to tell some kind of story to connect that model to real planets, right? So, okay, how we're going to factor in some of the idealized elements that were ruled out for mathematical reasons. And we get something a little less idealized, and slowly we get to something concrete, right? Now, the process of selecting certain parts and connecting to the world that I described is going to happen each stage of the way. So that's the way in which the highly idealized models would eventually get to something a little concrete, right? So And now, sometimes the model will describe something that doesn't exist at all, right? And it's, again, you overinterpreting some parts of that model accordingly. Right? So think about classical economics, right? You have this, again, great mathematics. I can solve these optimization problems, right? And say, okay, economic agents are going to maximize their budgets, right? And then I can solve the equations, right? Beautifully, right? And then I say, all right, this is what rationality is. If you're going to be rational, you should maximize your budget, right? And then you say, okay, how can I actually do that? I have to spend all my time looking at all possible configurations of how I'm going to spend my money, right, in the optimal way, right? And I have better things to do, right? So I look at something that's good enough and I just buy it, okay? Or some things that are way too expensive, so I just ignore them, right? So, Herbert Simon's coming along and so well, we're going to just satisfy it, right? So do something that is good enough, right? And that is a way of de-idealize, right? And adjusting, and then you have to make adjustments in the mathematics, right? Corresponding. I think, again, to understand this process is always a way of thinking, okay, which part of the mathematics I'm going to interpret back and which part I'm not, right? Now, if you ask about astrology, right? Now that's a completely different, right, way of thinking, because then you're trying to find correlations among moments that the day in which you were born, the configuration of the planets in the star, and how that shaped portions of your character, right? And well, are there things, right? Once I actually checked, I went to an astrologer, and he said, look, you need to be very careful with your head, right? Because there might be some accident in your head, right? And at some point you're going to be fascinated with prisons. I'm still waiting, but I lost my hair. Maybe that's. But I'm intrigued by prisons, but so far, that doesn't pan out, right? So the question is, how specific do you want the predictions to be, right? And the more specific they are, like the ones he made. By the way, he did something that he was right. He said, I was living in Brazil, and said, well, you're going to move abroad when you get married, right? So, and that happened, right? That made that. So something was right. Maybe a coincidence, a fluke, but okay, 20% right? It's not a bad, rate. So, but of course, as an empiricist, I'm interested in the sort of the evidence, right? And what is a good evidence to support those things? And ultimately, I think that's why I've been focusing on the actual phenomenon, right? Sometimes science will describe merely possible ones, right? Just as I think Newtonian physics was. But then you're describing just another model, right? You're not describing the world directly. At least that's the way I would think, right? And then you have to connect this other model to the world, right? And sometimes this is done through layers of models in between that try to, de-idealize some of the assumptions. At least that's the way I would think. I'm not sure if we address fully your question, but it's a good question. Difficult one, too. Right.
Well, thank you very much for your talk, and I have too many questions like Axel, I think, so I'll try to start with one. On the representation, because I have some metaphysical questions about model properties, but maybe we leave those for the second round if we have the time. But about the scope of your analysis,
right,
because you're presenting business analysis specifically about scientific models. One way of thinking about how they represent the whole world. Well, with its model properties of biologists in the world, I find it extremely interesting. Now, but how much of this applies specifically to models, and how much does it generalize to representational relationships in general? Because I'm not a philosopher of science. when you speak about models, I think like, well, yes, but is that just something specific, or does it apply to the representational version in general? And what would that say about, let's say, for instance, just one example, model language. You know, for instance, right?
You mean model language? Or?
Yeah. When we use language to speak about possibilities, right?
Okay.
But what would be the scope of what you call a model, or does your analysis perhaps also go beyond just models?
Right. Good. Of course, the analysis works provided that you can find mappings, right?
Yes.
Between empirical setups and things. They may not be models per se, right? But you need to find some parts of it, right? Yeah. So, but look, I do think it captures some aspects of representation that are not model-based, right? You can think about art, right? Think about paintings and pictures, right? So there are salient features in a portrait, right? That need not fully capture what is actually going on in the city, for example, right? And that's why portraits are so interesting. So if you think about the sequence of portraits that over the years Rembrandt did, right? He invented the selfie, right? The selfies are actually very interesting, right? And none of them exactly capture how he looked in any particular moment, but they capture something very important about the way he was facing the world, his concerns, his decaying age, his self, and all of those things are beautifully portrayed, right? Now, I would say there are connections between the way he looked, right, at any particular time, and each of these portraits. But the portraits also incorporate more. Right? They say something about his personality, they say something about his worries, right? And it's actually quite interesting if you look at them in sequence, right? As he started losing, his house, right? So the things piled up. The honesty in which he portrayed himself is actually very telling, right? So I think what was going on there are mappings, right, between himself, right, and his representations, right? So I think that it will capture certain things. You can do similar things with novels as well, right? So often science fiction can be so illuminating, exactly because it keeps certain features of the actual world and change others. And then in reasoning counterfactually, you think, how could these things be, right, if these other things were a little different, right? And then, of course, you're not saying that they are going to be that way, but they could be, right? Historical novels, right? There's a beautiful novel called Homegoing, right? Ghazi wrote. It starts in the 17th century in Ghana, right? And you have these two half-sisters. One was born to and give it away to the slave trade and move to the United States. The other one was assigned as a bride to the British person who was running the slave trade in Ghana, right? And each chapter of the novel follows what their siblings and siblings of that's in each side of the world until today. It's breathtaking, right? So it's impossible not to read the novel and understand the plight of African Americans, right? Probably in a much more compelling way than if you read a history book with all the data and information, because you can get and you see what's possible and what may have happened, right? In a beautiful way. Now, obviously, there are connections between Launching, even though the characters are all fictional. There are connections between the reality that she's portraying and what happened, right? In slave trade, in both sides of the Atlantic. And so there are maps, right, between actual historical events and what's being portrayed in this movie plus. And I think you learn something about what's possible by reading this novel. Right? So yeah, I do think that there's a larger story to be told, and but of course today I'm just focusing on one part of it.
Thank you.
Jim.
Thanks. I have two questions, but they are related. So the main question is that to avoid the challenge of models referring to non-existent things, you rely on the possibility of selection.
The possibility of
Selection.
Uh-huh.
So you select some pieces of the model
Right.
to reinterpret them as they are interpreted in the real system. Now, some people have argued that models don't decompose that way, that idealization are more holistic, and you cannot, separate the pieces that are corresponding to something real and from the pieces and other pieces that are, we can ignore the infinitesimal pieces of rabbits.
Mhm.
That sounds actually very gruesome.
Yes.
Sometimes. So my question is, how is that working? How is the selection working? And the related question is, you also, by doing this, you also rely on some notion of empirical adequacy. Now, and you're using theoretical models in ecology, and there's a long history in ecology of people saying that theoretical models are not empirically adequate,
Yeah.
and they actually don't predict anything about any real system.
Yeah.
And so my, related question is that, is it,
How about
that?
Great questions. So I think you only get the decomposition problem because of the reification of taking. So look, you have to take the model as a whole, and I'm denying that. I don't think that that's the proper way of thinking, right? Because what prompts that thought is that, every part of the model corresponds to something. And if you take that to be the case, then you say, I cannot decompose because all these things are talking about something else altogether, right? And I think, no, in the model, what you're doing is you're giving a mathematical representation. And at that point, you're not talking about anything that exists, because you're talking about functions, numbers, sets, and these things do not correspond to anything in the world in any case. So what you're doing is you interpret a set, right? And the interpretation is selection process. You're going to pick out certain features. Just as when you pick out in the empirical setup, I'm picking out certain features for representation. I'm interested in the number of preys and predators. I'm not interested in their size, right? Or the shape or the color. Right? So I'm selecting that aspect and mapping that into the model. Others I'm ignoring. I'm going to do exactly the same thing when I interpret the result back. Right? So I'm not going to take the entire thing, everything in the model, as being relevant. Right? I'm going to select those. And I'm going to select those on the basis of, what makes some empirical sense, because that's what I'm trying to accomplish. That's something I am doing. So I have control. It's not that the model, it's something that, I have nothing to do. I'm selecting these things, right? And the good physicist, the good applied mathematician, is the one who is actually able to make those selections in a way that is interesting. Now, don't know ahead of time, right? Some of those interpretations might be wrong, right? Dirac did 3 times, and he was a pretty good physicist, right? To get it right, right? The first 2 were wrong, right? One he ignored, the other one he got something that was empirically false, right? So, but what he was doing was indeed interpreting. He was selecting certain parts of them, right? So I disagree that that's a feature of scientific practice. In fact, scientific practice is not holistic. It's piecemeal, right? And it is case by case, little bits and pieces, right? And I think it's the idea of holism that actually generate a lot of pseudo problems in philosophy, right? So you have the fine sort of holistic picture, and then so look, it's the entirety of our conceptual scheme that get tested. No, you test a tiny little hypothesis here, you get a lot of other things out fixed. And in fact, you can test a part of the theory against another part of it, right? The bootstrapping methodology. That's how Newton tested his own theory, right? Scientists do that all the time, right? So I think the assumptions of the idea that the model is going to decompose that way is mistake. Again, it's assuming a form of holism about science that I don't think is correct. So I resist that. And once I resist that, I'm able then to select, as scientists do, right? They select the relevant bits and pieces. Now, the second point raised the issue of empirical adequacy. I agree that not every model in science is empirically adequate. And several of them, scientists know that they are not. And they should stick with it because sometimes they don't have anything better. Now, think about models. I live in a part of the world in which hurricanes are very real, right? So a big part of, have an entire school at the University of Miami dedicated to study hurricanes, right? And I often talk to my colleagues there, right? And they say, look, we have these incredibly detailed models of hurricanes. They give you very fine-grained information about the path, the intensity, and so on. They can only be run in supercomputers. They're extremely expensive to run those things. We have those much cheaper, easier to operate, empirically inadequate models, but they are good enough. And one of my colleagues in the Erasmus School would say, I think it's a mistake to also go to the expensive ones. The lower ones are actually good enough. They get the job done. You don't have to spend all that much time running these things, right? Or that much resources, right? So there's a trade-off. We know that the model is empirically inadequate. It doesn't capture all the details, right? It gives you rough enough, but it's good enough to say, hey, you don't want to stay there, right? Move out, right? And so even though it's not empirically adequate, right? The model is going to generate certain things that are not accurate, right? Same thing go for ecological models, right? So I think biologists are right in distrusting some of that, right? The Dr. Voltaire, I showed you that when you look at the actual data, the whole thing is all over the place, right? So if you want to be strict, it's not empirically adequate, right? And in fact, the model has so many idealizations that it's not, technically, it's not really describing, right? If you were to take the model seriously, right? Real rabbits, right? But if you want to take, my point is, if you want to take it to describe something in the world, well, that's what it's meant to describe, right? Yeah, I think empirical adequacy is important, right? But it's not the only criteria. And sometimes if you don't have something better, you stick with things that are not even empirically adequate, right? And scientists will do that. Of course, if they have something that is better, then it's equally better or so, they would just go for it, right? But it's still, by and large, empirical adequacy, I think, is an important criteria, right? And it will count against a model, right? So Bohr's atomic model, right, of the atom, right? It's a little planetary model, right? And then that according to electrodynamics, it would be highly unstable. In a matter of seconds, the electron would just crash into the nuke, right? Bohr setting up the model at a principle. This is not going to happen. All right. So now he knows that the model is false, right? It's incompatible with an extremely well-tested theory, right? But the model got the boundary sequence right? And they didn't have anything better at the time. And so physicists paid attention. So, okay, all right. It took, another decade until quantum mechanics was developed until this. But to this day, we don't have a good model of the atom. Right? We don't know what an atom is like. Right? I have no idea. Right? So, then you have a choice. You have a model that is false, but at least give you some idea, right? Or you have nothing, which you go to do quantum mechanics gives you, right? For the says, well, realize that's a mistake, right? There's a cost, right? So, and I think science is, always about trade-offs, right? It's about, you lose something, you gain something, and you try to adjust. That's what empiricists say. It's case-by-case basis, right? You're not going to get a whole unified theory from you, right? Empiricists are very skeptical of theories like that.
Otávio, be complete, please. We have more questions.
Okay, sorry. All right, I'll be. But there's not to be said. But
That's enough.
Thank you very much for the talk. Always it's very enlightening. I have a short comment about experiencing possibilities. There is an example of another kind of empiricism Mach when he talked about setting and Klein thought experiment, and said that we can imagine how this system works because we never have experienced virtual movement machine. So that's something that I think could be useful.
Yes. No.
Another thing, it's related with your question about the idealization. I will say that what you propose about comparing the model possibilities and the conclusions of the model with the empirical setup maybe implies some kind of the idealization of the model, and that smells like realism. What do you think?
Good. Yeah. So good. So about the second point first. So of course, the empiricist is a realist about the observable, right? So when you compare with something that you can check and it's observable, sure, you want to be realist about those things, right? And of course, if you're dealing with things that are unobservable, right, then the empiricist will be more cautious, right? You may say, look, I'm mapping these things. I don't know what they are. I don't even know whether they exist, right? So, so I gave the example of the positron, right? And then we say, so you're realist about the positron, right? Well, complicated, right? In part because we don't know if electrons exist, right? In fact, according to quantum field theories, there are no particles, right? We have fields and scintillation of fields. So technically, there are no electrons, right? As primary constituents, right? So where is the positron then, right? And so it is then that requires, at that point, we're interpreting the content of the theory, right? And that's a separate issue, right? I would say. But I think you can apply the model as a user and be a realist at the end and say, yeah, this thing exists, or suspended judgment. Okay. The implication is, well, there's something there, I don't know what it is, right? And Mao is a very interesting case, right? So I think he was an example of a good empiricist in some respects, right? And I think in a way the way he was taken by the positivists, I think also distorted some of his a little more thoughtful engagement with the science, right? And but you're right, right? I think we can think of possibilities, right? And consider even things that we know do not exist. Thank you.
Okay, so we're running out of time, so we're going to join questions. First, Maria and Enrique, and then.
Excellent, Mr. Okay, good. And you have to be efficient.
Okay.
So
that means wait.
my question is very connected to Josim's, because it's not so clear to me that you can get rid of holism, especially it came up from access question, because when you're saying yes, don't get into verification here, it seems adult, right? That you're going to say, oh, now here I really don't want to commit to this part because. And especially if you think about what we have been discussing in inconsistency in science, that these type of moves, they are very ad hoc and we shouldn't be pursuing them. So maybe reification is the strongest word that we are using here, but it's not so clear how you can cut the commitment from saying, this works for me as an empiricist, and suddenly all these theoretical parts that are connected to this, they don't, because I am an empiricist. So, can you say something about this very briefly? But then we have to listen to Enrique's question and then we reply to both. That is the idea.
Okay.
All right, just very quickly. So, based on your question as well, I cannot help but feel that some of the frictions that are coming from models, from formal systems, actually arise from the sort of kind of formal systems that we're using, which inherit some of Newton's and Descartes' ideas of separating things and then talking about the constituents, not about the relations between the constituents. So people like Aloysius Louis, Conrad Waddington, Nikolai Rajewski, and Rob Rosen would actually say that maybe these frictions come from the fact that you're trying to talk about the world using a sort of math that doesn't actually tell you anything about the world. So you're learning a lot about the model in terms of its inferences, but that really gives you nothing about the world itself. So instead of just, they would say, and I agree with them, instead of just saying, well, that's life, they would say, no, you need to find a different sort of math that actually tells you something about the world. That is, that when you encode the causal entailments world, you can actually decode the inferential ones into real predictions and not just some ad hoc chosen or pre-selected ones that represent behaviors that you actually are interested in. Otherwise, you can just find yourself in a situation in which the machine metaphor, the string manipulation machine, like the Turing machine, tells you a lot about certain aspects of reality, but then it tells you nothing about which strings I'm made of, right? So I just want to ask you, have you considered that maybe the formal system is the issue, and that maybe there is another way of formalizing nature that allows for a much better, more comprehensive, not total, but almost entirely interpretation?
Good. No, yes, yeah, the answer is yes. Right. I am very skeptical of set theory, for example. Right? I think there's a bunch of assumptions in set theory that are highly misleading, right? And there are very different kinds of mathematics. Some of them are much better, right? You have inconsistent mathematics, right? To account for accommodating inconsistent phenomena. But I think some aspects of quantum mechanics are better dealt with on the changing underlying logic. Right, of quantum logics as a way of representing some of those things. Yeah, constructive mathematics illuminates a whole plethora of aspects. So you have more informative information about bits of information about proofs and about the objects that you're dealing with. And it can, as you suggest, encode into the mathematics some of the relations you're trying to get information of. It's interesting when you're doing that. The way I would describe that is. In your immersion step, right, you are already setting up the model with constraints from the empirical world, right? Okay. And then you're going to do the same thing in the interpretation because you already have the mathematics are going to be constrained that will force you to be constrained also in the interpretation back, right? But also I agree with you that mathematics alone doesn't say anything about them, right? The mathematics talks about functions, sets, numbers. None of those things are in reality. So we will need to interpret that in any case, right? But I would say, as a good empiricist, the more the better, right? We explore various possible frameworks, right? And that, including changing the underlying logic when it's appropriate, that would also change what you can or cannot derive, right? So yeah, I think I'm fully on board with that, right? And now with Maria's question about holism. Right. So, yeah, in fact, I don't think that the scientific practice is holistic in this way. Right. So, in part because scientists are operating with separate hypotheses. Right. In fact, a lot of their work, often it is to separate, possible confounding variables. Right. And then they spend quite a bit of time distinguishing things, separate, okay, is this a relevant parameter or not? Right? So a lot of the work's actually separating rather than lumping things together. That's the whole point of also idealizing. You simplify so you can focus on something that it's all right, but it's good enough to capture a certain class of phenomena. Right? Now, when you're interpreting the results, right, back, sure, it is a selective process. We're going to select certain features. There is no other way, right? And now, the issue about because you then mentioned the issue about the holism in the logic, right? So, well, when you have your underlying logic, right? How can you do that, right? And so, well, there you cannot separate as it. And I think what happens there is logic, because it applies to the entirety, right, of the framework you're operating. That's why you cannot say, oh, look, it only happens to this bit, right? If you have a system that if your logic is explosive and there is some contradiction, well, it doesn't matter which part you're considering, because that will infect the entire thing, because the logic goes for the entirety of thing. Unless you're a logical pluralist. And what a logical pluralist does is to start chopping things and say, hey, I'm going to apply this logic to this class here, not to this other one, right? And once you start separating these things, this again, a way of not being holistic, right? You're saying, look, you need to be sensitive. Where is it in the domain of application of those things? And it turns out it's not unified, right? It's bits and pieces. Again, that's being an empiricist, right? The logical space is actually richer and interesting, but it's not unified, right? A whole bunch of things, and we don't even know all the possibilities that it may encompass. We'll find out.
Thanks, Raj.
Right. We have one more question.
No.
No. Just we need to be
Okay.
efficient.
I'm sorry.
We have
Yeah.
No, that's not your top tips.
Yeah, I think
I can ask later. So you'll decide.
So let's take Otávio.
Yeah. Thank you.